So in this section, we're going to introduce the idea of what is called a Venn diagram, and then we're going to talk about how to use that Venn diagram to calculate probability. All right, so let's begin with a definition for the Venn diagram. So a Venn diagram is basically a picture that shows the relationship between a sample space and an event. All right, and you can see a Venn diagram in the picture below. You can see that it looks like typically one of two options. All right, so in this first one on the left, all right, you have an event A, all right, and you have an event B, and notice that the circles intersect. So that means that there is some outcomes that are common between the two events. In our second picture, notice that the circles are entirely separate. So that means that the events have nothing in common. All right, so let me give you an example just to make this make a little more sense. Let's say that we are looking at a deck of cards, and let's say event A is a red card, and event B would be the set of black cards. So when you think about those two groups, they are entirely separate. You could take a deck of cards and you could put all the red cards in one stack and all the black cards in a separate stack. All right, so you could do red cards right here and black cards right here, and you would have two separate events. Okay, what if instead of saying red cards and black cards, we said red cards and aces? All right, so in that case, I can't separate the two events completely. Like if this is my red card stack and this is my ace stack, keep in mind that there are going to be two cards that will fall in here. There are two cards that are red and aces. So we have to have that intersection of our two circles. All right, so the Venn diagram shows that relationship, shows whether the events are completely separate or whether there's kind of an intersection between the outcomes. And we can use that Venn diagram to find probability, which is what we're going to work on in this section. All right, so I want to start with trying to look at an example, and let's be sure that we can take our data and actually put it on a Venn diagram. All right, so we have a class that has 50 students. And we're told that 22 students like football, 19 students like badminton, and 6 like both. All right, so I'm going to go ahead on my diagram and I'm going to label my two circles. So I have two sports, so I'm going to make this circle the football circle, and I'm going to make this circle the badminton circle. All right, and the first thing I'm going to look at is that it tells me that 6 students like both. So that means that there are 6 students who are in the intersection of those two sports. All right, so I'm going to go ahead and put the 6 right here. Those 6 students like football. They also like badminton, so they're going to be in the middle section of our Venn diagram. All right, the next thing I'm going to work on is this 19. 19 students like badminton. Okay, so this is the part that is a little bit difficult sometimes. So what this is saying is that in the badminton circle, all right, so inside this yellow circle that I'm drawing, you need a total of 19 students. All right, so you want to keep in mind that you already have 6 students sitting inside the yellow circle. So how many more do you need in order to make a total of 19? So I'm going to come off to the side somewhere, and I'm going to say 19 minus the 6 that I already have. That tells me that there are 13 other students who like badminton. All right, so again, you want to be sure that when you're setting this up, you look at the entire circle and make sure that the total in the circle is equal to the total in the problem. All right, so now I'm going to do the same thing for the football. So we're told that 22 people like football. So when I look at the football circle, the whole football circle should have a total of 22 students. All right, again, we already have 6 inside that football circle. So how many more do I need? So 22 minus the 6 that we already have, that's going to be 16 sitting out here in the circle. All right, so now we have a total of 22 students who like football. All right, and then the final thing that I need to look at is the fact that we have 50 students altogether. So I need to be sure that all 50 students are accounted for. So looking at my Venn diagram, I'm going to add up these 3 numbers. So 16 plus 6 plus 13, okay, that gives me 35. So 16 plus 6 plus 13 gives me 35. So I have 35 students in the diagram, but we know that the class has 50 students. So where are the rest of the students? The rest of the students would be people, when you ask a student, do you like football or badminton? They said, no, I don't like either one. Okay, those students, and let's see how many there would be. Let's see, we've got 35 accounted for, so that would leave me, those 15 students are going to sit in the box somewhere. Okay, not in the circles because they don't like football, they don't like badminton, they don't like both, they like none of that, so they will sit in the box, but not in either of the individual events. Okay, so that is how we construct a Venn diagram for a particular problem. All right, so now let's look at how we use that to calculate probability. Okay, so this is the same diagram that we just constructed. Okay, same problem. We're going to go in and we're going to answer some probability questions. Okay, so first of all, let me remind you that probability most often is written as a fraction. Okay, and so we want to find the number of students that meet the condition that the problem asks about, and then we want to put it over the total. So I know that on all of these problems, there are 50 students altogether. So I can go ahead and fill in the total at the bottom. Okay, everything's going to be out of 50 because there are 50 students in the class. All right, so now I'm going to go to my diagram, and the first problem says, how many students like football or badminton? Okay, so remember that with an or, it just means that they have to satisfy one condition. They can satisfy both, but at a minimum, they just have to satisfy one condition. So let's look at it individually. So these 16 people, do they like football or badminton? Yes, they like football. Okay, what about these 13 people? Do they like football or badminton? Yes, they like badminton. Okay, what about these 6 in the middle? If I go to one of these people and I say, do you like football or badminton? They're going to say, yeah, I like both of them. So it's still a yes. All right, what about these 15 at the bottom? Do you like football or badminton? They're going to say no. All right, so those are the ones that we want to exclude. We want to keep in everybody else. So 16 plus 13 plus 6 is going to give me a total of 35. And then we're going to reduce that fraction. Remember that you really should be reducing these fractions using your calculator. Okay, that fraction is going to reduce to 7 over 10. All right, so that'll be our answer on that problem. All right, so the next one says, what's the probability that a student likes both football and badminton? Okay, so hopefully this one feels a little bit easier to you. How many students like both? Those would be the people in the middle. It's not these only like football. And it's not these, they only like badminton. And it's not these, they don't like either one. So it's just the 6 in the intersection of that Venn diagram. And so again, we're going to reduce that fraction on our calculator. We're going to get 3 out of 25. All right, and then our next one says, what's the probability that they like badminton? Okay, so again, look at it piece by piece. What about these people? Do they like badminton? No, they only like football. What about these people at the bottom? Do they like badminton? They would say, no, I don't like either sport. Okay. These people, do you like badminton? They would say yes. These people also like badminton. They're in the badminton circle. Now, they also like football, but the only thing we're looking at is, do you like badminton? So those 6 and that 13, add it together, we're going to have 19 out of 50, and I don't think that one reduces. Okay. All right, so we're going to look at one more set of examples with this same problem. Okay, so I'm just going to clear our screen here, get some different questions up. All right, again, 50 students in the class. So when you're doing your probabilities, you know automatically that there are 50 students. So that 50 should be on the bottom. All right, so how many only like football? Right? So not these, because they like badminton. Not these, they say I don't like either one. Only like football. So not these, because they like football and badminton. Only likes football would just be these 16. All right, and again, we're going to reduce. I'm using my calculator to reduce 8 over 25. Okay. All right, so the next one says, what's the probability that they do not like either football or badminton? So how many of these people are saying, I don't like either one? All right, and so we know that that's the 15 at the bottom. These people are saying, when I ask them, do you like football or badminton? They're saying, no, we don't like either one. Okay, so that's the 15 that we're looking for here. 15 out of 50 is going to reduce to 3 out of 10. All right, and finally, we want the probability that a person does not like badminton. All right, so we need the people who don't like badminton. So these people don't like badminton because they don't like either sport. These people also don't like badminton. They only like football. Okay, these do like badminton, these do like badminton, they're in the badminton circle. All right, so I'm going to add the 16 and the 15, that makes 31, and that does not reduce any further. Okay, so hopefully that helps you see how to set up a Venn diagram and then also how to answer probability questions based on that picture that you have.